Hi, you guys. So we are going to go ahead and we're going to go through our study guide real quickly. We have a couple of things to go ahead and to work on and to review. So we're going to start by going over heat and temperature, and then we will go from there. So we got a few things that are going on here. First and foremost, we are going to be going ahead and talking about the direction in which heat flows, right? So heat flows, you guys got to remember, we go from where it's hot to where it is cold, right? So it basically flows from hot to cool, right? And you guys got to think about it this way. If we have like something that's really warm, right, and we go ahead and we put it on a counter somewhere, over time it's going to cool down. So where it's very, very hot, it's going to go ahead and it's going to cool down, and the goal is to go ahead and to kind of equal out the temperature, right? So we're trying to make sure that the temperature of that is equal. Okay, so getting into that, what is temperature? So temperature is basically how fast molecules are moving. So as the molecules are moving, right, the temperature increases, right? So basically molecules, the more they move, the higher temperature they are. So moving increases temperature, right? Heat is slightly different, even though we kind of go ahead and we kind of use them interchangeably, right? The two things are very, very different from each other. So when we're talking about heat, right, we're talking about how much we have in addition to the temperature, right? So heat is quantity, or how much, and how fast the molecules are moving. Right, so those are the two things that kind of go into heat, right? So on these things here, we have a time versus temperature graph. The only thing that I want you guys to do in this thing is to go ahead and to make sure that you guys know time and temperature goes here, right? And then we'll kind of move on and we'll kind of show this, right? So now we're going to go ahead and we're going to set this up. So we have time, and then we have temperature. Right, and then now we're going to go ahead and we're going to talk about how would it look like for something that is cooling, right? So if we go ahead and we start off with something that's really warm, so at a high temperature, right, eventually it will drop down, right, into a cooler temperature, right? So something that's cooling is going to go ahead and it's going to kind of have a downward slope, right? So then how would a temperature over time graph look for something that is heated, cooled, right? So heated, cooled, and reheated. Right, so then we're going to do our same thing on here. We have our time and we have our temperature. So we start off with something that's really warm, right? It goes ahead and cools down, and then you go ahead and you reheat it, right? So if we start off with something warm, cool, and then reheated, right? So this is a high temperature, this is a low temperature, and then that's one temperature that goes ahead and that is going ahead and being created again, right? So that's kind of some of the things that I want you guys to kind of see on there. Okay, so next thing, we're going to go ahead and we're going to talk about earthquakes and stuff real quickly, right? It says, explain what causes earthquakes. Use words like heat, convection, plate boundary, subduction, and heat flow, right? So when we're talking about this, right, we're talking about what is going to be causing earthquakes, right? So we have to go ahead and relate everything that we've learned, right, to go ahead and to talk about how can earthquakes happen. So in this case, right, the main thing is that the mantle convects, right? So the mantle convects, right? And the mantle is always going through convection. So our mantle is always kind of like flowing, right? And because the mantle is moving, right, the mantle goes ahead and the mantle moves the plates, right? So the mantle goes ahead and it moves the plates, right? These plates, right, they move at plate boundaries. So the plate boundaries will go ahead and the plate boundaries go ahead and crash into each other, right? And so plates collide, right? And these plates will go ahead and those plates will collide, right? They will move past each other. they will kind of get that stuff going, right? And then what you guys will see is that we have that whole cycle of heating, cooling, heating, cooling, heating, cooling, right? And that is how the mantle is flowing. The plates are colliding, they slide past each other, and then energy is released, right? So those are kind of like the things that we're kind of looking for on there. Okay, so density of a metal ring, right? So this kind of relates to our lab. So density is equal to mass, right, over volume. And we go ahead and we're looking at this and we're relating mass over volume. We have our mass over, we have to go ahead and we can weigh out our ring. So our first step is to go ahead and to weigh ring, right? And we're going to go ahead and we're going to get our mass out of that, right? The tricky part is to use a graduated cylinder to get our volume. And how we do that is that we go ahead and we use a graduated cylinder. We go ahead and we see how much the water level is raised by. And looking at how much that water level is raised by, we can go ahead and we can get volume, right? And then last but not least, you would go ahead and you would do your mass over volume, right? So it's the same thing on there for this one. So D is equal to M over V. So I have M over V. Now I go ahead and now I look at that. My mass is 80 in this case. And then my volume is 53 centimeters cubed. Right, I go ahead and I divide those things. So super duper simple. Right, I go 80 over 53, and I should get 1 point something, yes. So I should get 1.51 grams per centimeter cubed, right? And I do the same thing on here. They ask me, what is the weight of ethyl alcohol that fills 450 milliliters in a container if the density is so? So same thing. Right, I go D is equal to M over V. What I will see is that I have to go ahead and I have to change up the equation. So if you guys remember, we had this triangle that kind of looked like this, right? And we can go ahead and we can solve for density. But in this case, right, we want to go ahead and we're looking for mass. So what you would do is that I'm going to go ahead and I'm going to cover the mass real quick. Right, and I see that when I cover that, I'm going to have D times V. So if you guys remember, right, when we go ahead and when we do this, you have to remember that when you go from top to bottom, you're dividing, and when you're going across, you're multiplying, right? So in this case, so M is going to equal to D times V, right? And then when I go ahead and when I do that, I'm going to go ahead and multiply 0.789 grams per milliliter times V, which is 450 milliliters. My units cancel, so I go ahead and I multiply those deals. So 450 times 0.789, and that is my mass is equal to 355.05 grams. Right, so that is your thing on there. Okay, so going back and looking at our phase change graphs, we got a couple of things that are going on. What I'm going to do is that I'm going to kind of combine some of the things that you guys are going to see towards the bottom, and we'll kind of combine some of those definitions. So first thing to know is what each of these letters mean. So we're going to start with A, C, and E. So A, you start at the bottom, and over here it is a solid, right? At C, we are at liquid, and at E, we are at a gas, right? So now we have to go ahead and we have to identify what is in B and what is in D, right? So now you have to think about what are the names. So when we go from solid to liquid, right? So when we go from solid to liquid, right, if we're going this way, right, it's going to be melting. If we go from liquid to solid, right, that is going to be freezing. Right? That's not spelled right. So you guys go ahead and you guys go to freezing. Right, same deal on here. I'm thinking about what happens when I go from liquid to gas, right? So if I'm going this way, that's going to be evaporation. And when I go ahead and go from gas to liquid, that's going to be condensation. Okay, and there's a couple of more that I'm going to go ahead and I'm going to kind of fill in on here, which is going to be sublimation, right? So your last one is going to be sublimation, which is going to be when we go from solid straight to gas, right? The special thing about sublimation is that you're not going through the liquid phase, is that it just goes ahead and goes straight to gas. Okay, so next thing on here, convection. So convection is pretty much this circular movement that you guys kind of saw with your chia seeds. Convection is anything that is hot, so the heat is going to rise, and cool, it goes ahead and falls. And it's going to be going ahead and it's going to go in that pattern, right? And it goes in that pattern, right? And it continuously goes in that pattern as long as it has like that heat source, right? Conduction is going ahead and passing heat molecule to molecule. So an example of this is when you guys are going ahead and like if you put like a metal in a really, really warm spot, right, the metal is going to eventually get warm, and that's going to be your conduction. Your radiation is going to be like heat that travels through space. Right, so in this case, it's usually light. So it's heat or light energy. So you guys have to think about the sun in this case, right? So think that we are getting like heat from the sun, and that heat from the sun is going ahead and that thing is getting us warmer. So those are the things on there, right? And then we have condensation, melting, freezing, evaporation. We already went over that. Okay, so different types of plate boundaries. Right, so what I want to talk to you guys about here is your three big types of boundaries, which is going to be, your first one is going to be the one that goes ahead and it's going to collide, right? We're talking about colliding. We're talking about going ahead and plates sliding past each other. And then we are going ahead and we're talking about plates separating. So those are our three types of plate boundaries, right? The formal names, right, is now going to be your transform boundary, your convergent boundary, and then you have your divergent boundary. Right, so divergent means that we're going ahead and we're separating, right? Convergent means it's a collision, right? And then we have our transform, in which we go ahead and we slide those things past each other, right? The main thing that I want you guys to kind of see here is that in this section, right, make sure that you guys know what a subduction zone is. So in a subduction zone, one plate sinks. So when you have the one plate that sinks, it's usually going to be your ocean plate. And that ocean plate is going to be sliding past your plate on there. And there's also the continental plate. So your ocean plate sinks under continental. Right, so our oceanic, well, this should be our oceanic plate. And oceanic plate is obviously the ocean, right? Continental plate is obviously land, right? So those are our two things that I kind of want you guys to kind of be aware of, is those two types of plates, right? Our oceanic plate is going to sink under because it is more dense, right? And because it is more dense, right, it's going to go ahead and it's going to sink under, right? Okay, last two questions. Okay, so we're going to go ahead and we're going to talk about this sample right here. So in a 310 gram sample of liquid of water that has this specific heat at 30 degrees Celsius ends up at ice at 25, right? How much energy is involved in this change? So this is our Q equals MC delta T, right? So if I go through this, I can identify this as my M, I can identify this as my C, and I look on here and this is going to be my delta T. Right, the trickiest part about this problem is that our T final is negative 25 degrees Celsius, right? And then our initial is going to be our 30 degrees Celsius. So we have to see that this thing is going to be final minus initial. So negative 25 minus, right, 30, right, degrees Celsius. And again, I'm looking for my delta T. Right, so I'm going to go ahead and I'm going to subtract those two numbers from each other. Right, so I'm going to have negative 25 minus 30. Right, so when you guys do this, you guys should get negative 55 degrees Celsius. Right, so that will be kind of your trickiest part on here. Right, and then I obviously have my C, joules over grams degrees Celsius. Right, and then my M, which is 310.3 grams, and then is equal to Q. Right, so I go ahead and I check my units. I see that I have joules. I see that I have grams. Right, so that's all good. And then when I go ahead and I'm able to go ahead and able to multiply this number. So 310.3 times 4.186. Times 55, right? And then I should get 71440.369. And it's going to be a negative number of joules, right? And the reason why it is negative is, again, that we're going through that freezing process, so that number is going to be negative, right? So it says a body of mass, which is 2.5 kilograms, absorbs heat of 670 joules when the temperature rises from 20 degrees to 70 degrees. What is the specific heat of the body? Right, so I go ahead and I pull those things out. Q is equal to 670 joules, right? And I know that because it's in joules. My mass is 2.5 kilograms. And you guys will see that I'm going to have to fix that into grams in a sec. And my delta T is 70 minus 20, right? So that would be 50 degrees Celsius. I'm going to have to move this thing over. So King Henry died drinking chocolate milk, right? Go ahead and go 1, 2, and 3. So I go ahead and 1, 2, and 3. So I'm going to add 2 zeros to that. Joules and, oopsies, that's grams. So then I'm going to go ahead and I'm going to solve my equation. So 670 joules is equal to my mass, which is 250 grams, times, it's going to be my C, which is what I'm looking for, and then my 50 degrees Celsius. And I go ahead and I divide both sides. And that should be it. And then if you guys go ahead and if you guys solve that, you guys will see. So going ahead and backtracking just a little bit, right? So now I have my equation set up. So now I have to go ahead and I'm going to be isolating this variable right here. Right, so what I'm going to do is I'm going to divide each side by the same thing because the inverse of multiplication is division. Right, so I go ahead and I do that, and I go ahead and I put this over here, and when I go ahead and when I put this here, I see that this thing cancels, that thing cancels, I'm left with C, right, so 670 joules over 2,500 grams times 50 degrees Celsius. I go ahead and I do that math real quickly. So 2,500 times 50, right? So this side, so I have 670 joules over 125, 123 grams degrees Celsius, right? So now I'm going to go ahead and I'm going to do that final division. So 670 over 12 grams. So then my C is going to be 0.00536 joules over grams degrees Celsius, right? And that is what you guys should get on there. Okay, so thank you guys for listening. I hope that these videos were helpful to you guys, and good luck on your test.